Hi, this is Kushwant. I'm very excited to come up with the new series related to long chain. When we come to um, RAG-based applications, the retrieval of the data from the vector databases is very crucial for uh, how we can provide this information and get the relevant answer for the specific question. That's where I have the comprehensive design plan or comprehensive guide in order to have the proper retrieval system for our RAG application, where you can utilize and plug and play with multiple scenarios based on your use case. For this, if you see uh, one approach, different approaches I will speak. So first of all, I'm using Facebook AI similarity search for storing the information, and I'm using long chain in order to have the retrieval from the FAISS index that we have created. Then we use different approaches. One is by storing the index locally, and other one is without storing. So the first one is not efficient to go through, but I will just show how you can able to uh, uh, ask a question and get the search results from the index using long chain and with different tools and agents that we can utilize in this approach. As well as next thing is like second approach is you can able to have the information loaded in your system and have this data being utilized and loaded back into for asking certain questions and get the relevant search results back for you. So for this I'm using two different data sets. One is NVIDIA. This is the web page I have taken, as well as about the DeepSeek. This is the two news informations that I have taken, which is latest one. And I'm web scraping it. I will show you the step by step by running as well. So first of all, I'm just initializing what is the query, what is the latest news. So here my agenda is based on our uh, documents that we are chunking and storing into the um, index. We need to ask a question and get the relevant latest news information from the documents. That's my whole idea over here. We'll see how we can do this. So in the first approach, this is a common where you need to web scrape the information that you are provided. So I'm using these two URLs if you see over here. So I added these two URLs where it will take this data web scrape from the website and can able to store into the uh, database. For this I'm using web-based loader and also FAISS vector database, and also I'm using for chunking strategy, right, recursive character text splitter, as well as I'm using some of the Hugging Face embeddings over here. So I'm taking the Hugging Face embedding like mini LLM from the Hugging Face for keeping it simple and for the simplicity. And I'm giving the uh, index name FISS as FISS index, and providing uh, this information while I'm calling the method. So here it is, we are loading and creating the FISS index. I will show you it is taking each URL of the list that we have and then parsing the splitting, and we are scraping and then chunking and then loading this information and having these documents ready, and these documents has been passed into the function in order to create the embeddings and in order to create the index. So let me run this. if you see, the index has been created over here, and also it's been saved. And yeah, this is the one. And now once I saved, I'm not loading the um, index from the saved location. Instead of, I'm taking the same vector db object and then trying to retrieve. I'm using the retriever function from the other, and then using retriever dot invoke directly. Yeah, behind the scenes it is just doing the regular similarity search and nothing much. Okay, if you see, we do have multiple uh, data over here. If you see how the data looks like in the result, so it by default it is giving me the four results over here, and we see how the results look like, the data inside. If you run this, this is the document object and it looks like this. And if you wanted to see the metadata, this is the source, title and description, and language. So if you see, one of the documents that we passed is related to the DeepSeek. So this is the title of the DeepSeek. If you see, what is the DeepSeek, why it is disrupting. So this is a one, and this is a URL. And if you wanted to see the page content of that, this is the page content. If you see, and one, if you wanted to see the how it has been indexed, I mean what is the vector of the chunk of the data that you are used, I'm giving index id 1 and trying to have the FAISS index, and reconstruct, and trying to pull the information about the vector. So this is the vector information. It has length of 384. It is based on the embedding model that you have taken. The embedding model that I have taken is smaller one from the Hugging Face, which is simple enough for the simplicity. I have using that one. And let's see how we can use the tools from the long chain tools and agents from the long chain in order to uh, have the answer for our question. Until now we can able to retrieve the results for our specific question, but we did not used this information to get the relevant answer. So what is the latest news is a question that we asked, but we got the search results for that specific based on the similarity search, and without loading it from the local and just directly using the vector db object. If you let me see, I'm just taking randomly one tool like date timestamp to get and seeing. See, this how you can utilize at the rate of tool. And for your information, I'm not using the latest long chain and long graph things like that. I'm just using long chain one first release version. I'm making sure that I'm using the uh, functionalities or packages and all those things which are not deprecated. I constantly referring to the long chain documentation where some of the uh, functions or some of the classes and things are being deprecated to import. But make sure you can use anything if you want, like 2 or 3 and long graph and things like that. But for the simplicity and having the very basic understanding in the core level, I'm just using the initial version of long chain. So if you see, this is how you mention the tool, like your custom tool over here, and this will return you the date information in ISO format. If you see here, this is the name, how you can get of the name of the tool, and description and arguments. So arguments, we no need anything, so you put it null. And if you see, the description provides the description, date and time of ISO. So this is the description, and the name is nothing but this one. Yeah, if you run this one, this gives this. And let me invoke and get the current date information, date and time. If you see this one, yeah. And another way you can retrieve the another way you can execute and get the information is in this way too. Can mention it as within the tool and give the function and run and description details. And if you run this way as func of tool input, and it can able to provide the information. This is another way you can get the response from the tool uh, by standalone calling it instead of within the agent. And other way is this thing. You can also use like dot run and provide the information. So one is like dot invoke, one is like dot func, one is dot like run. Three different ways. Yeah, and also another way here, invoke, as I mentioned, dot invoke. Okay, that's all. So once you created it as a tool here, so you are creating it as a tool object over here, and you can invoking in these different ways using func, run, and invoke. Just for testing purposes, I'm using it. Right now you can use long chain create retrieval tool in order to use this retriever object which we created earlier over here. If you see, this is the retriever object that we do have from Facebook similarity search. We have taken that one into consideration over here within this retriever tool, uh, create retrieval tool, and right now I can run this one. And we just see this retrieval tool. So I'm creating another tool for specifically to get the results from the retriever and use this tool within the long chain agents. That's where I'm preparing all this. If you run this one, get this one. Now you mention the tool in this way, like this one is datetime tool and retriever tool. I'm giving two tools in this format, so we need to pass this information later in the agent. That's why I'm preparing in this way. And yeah, and also we need prompt. So there are different classes in launching. It might be a different a topic to talk all about that. Let's say if you take long chain, go to long chain, and chain tools. Yeah, version 1 I'm taking. Go to components and tools, and if you go to tools, agents, yeah, agents and agent types. These are the different agent types. If you click on agents and agent types, if you see, there are many agent class types, and you can use any of them, but some are deprecated and things like that. You need to see, if you see some are legacy, no need to use a function call and things like that. Instead of, you can use tool calling, and make sure you are using the non-deprecated functions or classes from the long chain. So I'm using React, and I will show you while executing how the uh, React works. If you open this, this is the thing how you can use it. So you need to pull prompt, right, for this specific agents to utilize, for example, and LLMs to utilize. If you go here, I'm pulling the long chain, this particular from the hub to have the React template. And if you run this, if you see the prompt template and input information and metadata, and most important thing is we need the template, how the template looks like. If you see, this is the template. If you run this, this is a template, and I copied this one over here just to show you. Like, if you see here, answer the following questions as best as you can. You have access to the following tools. So that's where we are providing tools to the agent, and LLM will use this particular information that we have to utilize some of the tool objects and things to get the responses with the help of agent executor. So if you see how this those different long chain types are, long chain um, agent types and classes are like different patterns that go through. For this React, it will be first, it will be like thought, then action, and observation. Like, it will go through the thought, action, and observation. If it gives a final result, it will check with the LLM as well as a result, and if it is okay, it will provide the final answer. If it is not, it will go back to thought, do action, and do observation, and the process will be repeated n times. That is the design pattern that has been utilizing in the React class type. If you go through, okay, just executing. Yeah, and right now to utilize some of the we need to test this agent, and for our specific question, the goal is, for our specific question, we need the response from the search results that we have from the retriever. So for this, I'm taking few of the things like Groq and Google API keys. You can quickly set up all those things within the environment, which are open source, free to utilize. If you go back, this is the Groq website where uh, you can see the multiple models which are free to utilize. And also, in the same way, if you go through the uh, Google AI Studio, you can create the key over here and utilize in the same way. You have the key information, API keys over here. You can create one and you can utilize it, so that we can utilize these models, whatever exists in the Groq or whichever exists in the Google AI Studio. So you can do this kind of model inference, or getting the response for your specific question to answer using LLM and agents. So if you see, you can use Hugging Face model inference and get the response to the questions using tools and agent. I utilize this, but is if you see right now, the RAM is at 5 GB and it's not been utilized much, right? Once you start using this particular Hugging Face, the model gonna load into your local machine, where it will try to utilize the pipe and do the inference, and provide our question prompt agents. Using the long chain agent, we provide this LLM into the long chain agent and try to execute. I will show you. If you run this one, if you see, the RAM is going all the way up. Now the spike is happening due to utilizing the Hugging Face. See, 100% this is loaded, and just see the we are good with LLM tools and prompt right now, which is needed further. So here what I'm trying to do is I'm using the React agent class, our function that we have, and try to create an agent. This is the agent, and we utilize the agent executor. So agent executor helps us to which tool has, with the help of agent tools, it will try to queue the particular tool to be utilized for our specific question, because first it will, based on our prompt as well, right, based on our things, because it will first think and utilize the which tool has been proper here, uh, to get the response. Okay, let me run this one first. Okay, if you see what is the latest news. And I don't know, there is some issue with the Hugging Face models to utilize directly anything. If you say free, it's really not free. But something is better than nothing, to kind of to test it out and um, make sure something is working right now, and we can take it later on and utilizing it in the production level thing, right? So it's just like a POC, so it is good enough. So it will try to execute this thing forever, and not sure there is some issue with the model invocation and things like that from the Hugging Face, uh, which is already kind of an open-ended problem I have seen in the Hugging Face forums. They are trying to say. Let's see how long it will take. Probably it will end up with the error right now, which is kind of an bug or error from the Hugging Face. And wanted to let you know, here I'm using Llama 3.2 3B instruct model, text generation, so pipeline. Yeah. So whatever the response that we are getting using this Hugging Face model with the help of the pipe, it is not conducive enough, or it is not friendly enough to utilize by an agent. So agent cannot able to properly utilize it to give the response. So it's kind of an some incompatible situation happening over here. So these are the some of the challenges that I am seeing utilizing multiple multiple things while trying, like getting information from the Hugging Face, getting from Google API, and things like that. Probably you can feel free to skip this part if this is taking like 4 minutes, so more than that. See, agent is stopped due to it cannot able to mm, get the information, because uh, the format and the things that we are having from this LLM is not friendly enough for agent to identify and act on it. There was some issue, open issue. Okay, I think you can skip this part while watching video and going to this one using Google API. So Google is providing some free uh, environment for us to utilize their API and call the specific models. If you see the list of models that they have Gemini 1.5 family, and where I'm trying to use this one Gemini 1.5 Pro in my notebook right now. And there are some preview models which are experimental, and there are some Gemma models as well. So these are all you can try it for free over here. But there are free, but it is when they say free, it is not really free sometimes. So you need to have certain limitations over there. If you run over here, this one, okay, let me, second. Go back here. Here. Okay, let me run this one. And now executing this. So right now I have this LLM, and if you run this one, and same, I'm using the React agent over here and executing the agent using the agent executor, and let's see the response. I see there is an issue with this as well. I need the quota limits to be exceeded, where I'm getting this kind of an error over here. So I may need to try with another model or a request for the quota and things like that. I think this may not be free. I need to use some Gemma models or something else. So I'm skipping this part right now. You can plug and play with different other things there uh, based on your interest. Going here, I'm right now I will be using the Groq API. So again, this is the Groq API. If you wanted to see what are the models that are available, yes, there are a lot of llama models and Gemma to 9 billion 80, and also instruct, and also the Whisper and Mixtral. You can use any of them over here. I'm taking the Gemma model 9 billion, and yeah, try to in execute this and get the LLM. So if you see here, I'm using the create React agent, and then agent executor, and then invoke. I'm just giving question like what are the new advancements. See, the thought is a process and action, and trying to go to the new search which I am already been using in tools. That's where it is taking and searching for this information. And see it, and also if you see, if it is very fast enough to give the response. The recent breakouts in technology rises open source AI models like DeepSeek. If you see our result information, it's not that much diverse, but we have some NVIDIA information and DeepSeek information like Blackwell and DeepSeek related to what is project digits and things like that has been mentioned over here, and over here the DeepSeek models and things like that. This information is being utilizing right now from using the retriever object and trying to answer our specific question, and what are the new advancements, it can able to provide the information over here. And if you see thought, action and action input, and if there is needed any observation it do, or if achieve the final answer, it can able to provide you the final result. If you wanted to see more details about it, click on the text editor. You can see entering chain and getting all the input information and giving the final result over here. Yep, that's it. And let's try with our query, the query which we have taken over here. What is the latest news? Let me execute that. What is the latest news, right? Yeah, this one, query. Let me run this. Maybe not sure why it is not giving this time. It was giving good response before. You see, the latest tech news is the about DeepSeek, a Chinese AI model over here. That is the information that we got in similarity search using the vector DB object with the retriever. And if you go to here and ask what is project digits, NVIDIA Project Disease is a personal AI supercomputer that provides AI researcher, data scientists, and students worldwide with access to the power of the NVIDIA Grace Blackwell platform, which is a recent advancements of NVIDIA that is going to release in maybe in couple of months. This kind of a GPU, I think. I think this is pretty much like this. You can utilize tools, agents with different models in order to have. And if you see the response is fast enough to get, see how much fast this Groq API is. Thanks for the Groq API. As well as if you see the RAM, there is no spike at all. We are not loading, we are using the API. When you tried with the Hugging Face, yes, if you pay Hugging Face, you have the APIs, but in the free version of it, you need to load the model and do the inference. That's where got the issues over there. And just one more, just to test, like we do have different tools mentioned within the toolkit. So we just need to see if this execute it will pick the right tool to execute. What is the current date and time? See, it is taken the current date time tool and try to give final answer as this one. And this is about specific scenarios or specific ways of how you can get the response for your question with the retriever using Facebook similarity search without loading it locally. Now going forward, we see how we can load the load the information that we have here from the local into our notebook, and then utilize that and can run. If you go here, not this one, if you go here, steps to save, this one, I already executed this one, so you need to execute only once this one to save it right now. If you say here, while I am processing, I saved it here for the first time, so it has been saved. But I am using this vector DB object to get the search results instead of again loading it from here. But we see right now how we load and do the search on this index. If you go here, so and also approach, we'll talk this one later. So which is a why we need to load it, which is fast, because you don't need to reprocess every time the documents, right? You don't need to reprocess. Once you process the document and save it, the indexes and vectors will be available, and you can load it whenever is needed and you can reprocess only the delta information, or maybe the new incremental chunks of data, or new incremental documents are coming into place. Then only you add certain documents, that all the functionalities already been incorporated here. If you see add the documents, so where this is where we are adding the documents, the new documents. Let's say if you give any other documents over here, instead of this one, passing it the new document, it will just retrieve the existing vector db information documents, and then it will try to add the documents into the existing vector db. Yeah, go back here. Yeah, see, again, uh, you no need to load this one right now, embeddings. I already did this one in the above. I will just try to load this one again. I just maybe that's okay, I can have it, no worries as well. So I just use a load local functionality from the Facebook similarity search, and give the embedding and the path to the FAISS index. This is the similarity search index, that name that I'm providing. And if you run this one, and right now this vector, we are using vector store to retrieve instead of vector db directly. So we are storing this information from here, and then we are doing the retriever. And see, it is also faster. This is the information that we have. Same, this is a similarity search which is happening behind the scenes. And while talking about different kind of search we go through, if you see, by default this is the similarity search using as retriever, but I will also talk about all those different other kind of searches, that mechanisms that we have. Excuse me. If you see this one, you have the function called similarity search, where you can able to provide how many results you do want. For example, you need uh, top 6 or 7 or whatever, where here you cannot able to pass that information. By default it is giving you only the 4 documents to you. Run this one. See, now 1 2 3 4 5 documents are being given for our specific question. And this is the similarity search. And going to the text query search, instead of using the that it is using the full text search. One second, let me run this one. Yeah, so instead of directly using vector to search, it is just using vector similarity search. It is just using based on the text relevance, it is doing the similarity search. And I'm taking the k is equal to 3 over here and getting 3 results. If you see, maybe 5, getting 5 results, which is almost similar to similarity search with the vector with the text. This one got the same results, there is no difference. But only thing is, if you see the benefits, I will talk benefits later. Just see how the results are right now for each one of this. So if you go through the this one, instead of just documents, you can summarize the information as well. For this I am using uh, bought large CNN, and this is from the Hugging Face again. I just don't run this one right now because my uh, notebook will crash because it is already 15 GB right now. So I don't want to run this one. But if you see here, this is the information that we have. So we are loading it in this way, like sequence to sequence LLM, and passing this as a summarization and tokenizer and get the response. In this place you can utilize models like from the Groq or from the using Google API and AI Studio, where you can do some summarization tasks based on your prompts and things like that. But I directly took from Hugging Face, and if you see, I'm using the retriever, and the main thing is here I'm using the retrieval QA from the chains and try to provide the retriever and the LLM information and try to get the information about the uh, summarization about the text results that we got from the retriever, right? So I'm summarizing all the text content from the retriever using this LLM, using the chain. If you see here, the result looks like this. DeepSeek's breakthrough has seen uh, mixed reactions. While Microsoft and OpenAI CEOs praised the innovation, others like Elon Musk expressed doubts about its long-term viability. Disruptive invocations like DeepSeek can cause significant market fluctuations. So it is giving, but they are also demonstrated this rapid pace of process and inference competition driving the sector. So this is the nice summarization you can also do on top of this, and you can use this summarization for answering your question as well, and you can pass this summarized result to LLM via tools and the agents that I have shown. At the end I will show how you can use different kind of searches with the agents. And if you see here, uh, this is another way you can do. Let's say if your documents that you have over here from the retriever is too heavy for you to summarize for the model, in that place you can have different methods over here, like uh, stuff chain, or else like stuff chain in the sense you are pausing entire documents. Again, you may use map reduce and things like that. So but here I just, for the demo purposes, I just took the straightforward stuff and stuff chain, and you can use this stuff chain along with the create retrieval chain to pass it, so that it will give the text summarization based on the LLM and the prompt. And also if you see here, you can also pause the prompt over here. If you see, I can able to provide the prompt like taking only 3 sentences maximum and keep the answer concise. So that kind of feasibility has been available over here. Yeah, and if you want an entire result of the retrieval to be utilized for your summarization, yes, maybe probably you need to go with map reduce, not direct stuff over here. If you see still, it give me context and source. If you see the response, and this is the response and this is the answer. DeepSeek R1 is new Chinese AI through threaten OpenAI. The model refuses to answer, and it giving all the nice summarization about the 3 sentences that I have taken at the top. And other alternative, hybrid search. if you go through hybrid search, I given how this hybrid search working here. What is fetch k and k? So it's a marginal. It uses something kind of an algorithm like MMR, like marginal maximal marginal relevance. You can go through this documentation in the online and can see. If you see here, this is the document where uh, you have the information about how this has been re-ranked and re-ordered behind the scenes using this marginal relevance search. So using this marginal relevance search, we are giving the margin of 10 documents and taking 5 out of them. So in this, it is happening the re-ranking of the information that we are taking from the retrieval. If you run this one, and if you run this one, see, this is the retrieved information. So if you see, we do have diverse information over here, like NVIDIA, as well as with related to DeepSeek in the hybrid search. It's not only related to the similarity as well as diversify. If you see, it avoids redundant results and give the diversified uh, retrieved documents, useful when dealing with large document sets, like if you have different versions of documents or different kind of things. It balances the keyword match as well as a vector similarity to give the better results in the holistic picture. So right now the final decision is based on your use case and your. So for example, if you want quick retrieval, use the similarity search, and if you are really ready to have a index saved, then load, uh, most probably in the production or anywhere you wanted to have the data to be reside in somewhere in the, and use it from there loading, right? So based on that, and also whether you wanted to summarize and you wanted to use a hybrid search for your specific question like MMR and get the relevant answer, depends on that. And also given the all the nice description and detailed comparison about it, pros and cons of each and every kind of a thing. So, let's say hybrid search, it will give combines keywords and semantic search and cons. It's a computationally intensive, and RAG retrieval plus LLM, and which is nothing but summarized information, provides a summarized response, and retrieve LLM extra cost and latency, because you need to considering all the chunks of information that you are getting from the retrieval results in order to summarize, right? And again, if you are using just text query search, similarity search, simple and effective, might return less accurate result. And for the full for the if you want the full control over the search parameters, then go with the vector, where it will do similarity, cosine similarity and things like that to get the relevant answer for your specific question. And it requires manual embedding generation. So here we used mini LLM from the Hugging Face to manually uh, create the embedding vectors and store it them in the locally in the index, right? And also whether you are going with the local or not, local is better to load and have it available. Here it is local. In production environments, you can have it in somewhere and use it from server. And finally, we'll see what will be our response for the hype. For example, here I am using the hybrid search retrieval result to get the response for our specific question, right? Let me execute this one. So this is the search input and the custom search tool that I have been built over here, where I am passing the name of the search tool and the description and search type and search input as an argument, right? And then some private functions like run and async run has been utilizing, where I'm using this retrieval documents utilizing the max marginal relevance search, right? And I'm generating the results as a return response, and this is has been utilized in the model. So for this, I'm importing the base model to get the natural language query statement for our question, as well as the base tool, importing base tool for creating this custom search tool. If you run this one, and this is the custom search tool, and you can see custom search tool, it will be unwrapped in the, okay. And this is the tools I'm providing, like instead of direct retrieval search retrieval tool, I'm using this custom search tool, which I have been, because I'm doing this here, I'm not using directly the vector retriever as a vector retriever object or vector retriever function to get the default 3 or 4 results back with just a similarity search. I wanted to use this marginal relevance search and get these documents to be used for our search tool, right? For our search, that's where I'm utilizing this custom search tool instead of retrieval search tool. If you run this one, and you go here, and I'm again defining LLM, and now I'm using same create as we seen earlier, creating React agent and providing the uh, agent and tool in the this one, the agent executor, and then invoking what are the new advancements. Let's see what will be the answer. DeepSeek is a Chinese AI and open source low development and cost and impressive, causing a near plunge of NVIDIA. See, it providing all this information based on our diverse set of documents that we are provided. If you wanted to see what are the results that we have while asking the question with the agent, if you click on this particular thing, you get the relevant information over here, how the agent is thinking and observing and giving the output response. See, diverse information, see about NVIDIA as well. It is taking consideration all different diverse results, not just a similarity search, right? Not just DeepSeek information, or not just um, uh, project digit information. It is taking entire diverse information we are getting into the search result, where it is utilizing to answer your question for what are the new advancements. And if you go through this one, I'm just giving query. What is the latest news or something like that I given. The latest news is about project digit distribute and world's smallest AI supercomputer, giving the information. And if you go to again, just asking what is project digits. The project digits is a personal AI supercomputer, and it is giving all the information. And just to test like whether you can able to trigger different tool based on your question, whether the agent executor invokes or utilize the relevant tool. Yes, of course. So you can play with multiple models or multiple things, and you can plug and play with different other kind of models that you have available in the Groq as well as in the Google AI Studio. Yeah, this is pretty much the comprehensive design, end-to-end design of a retrieval process and also able to generate the response from using LLM based on our search results. Yeah, thank you guys.